Wonderful. Hi, Victoria. Hi, Victoria.
Hi, Professor.
Anything you got? Anything you
No,
need from me?
no, I'm just here for class.
Okay. You're a bit
Trying to get
early,
my-
but no problem. Things are going okay?
As good as they can be, I guess.
Okay, fine. What is that supposed to mean?
You know, work and life in general, you know, just trying to get by. The next 2 weeks are going to be crazy, so I'm stressing, but trying to get through it.
You know, bottom line, you're gonna do well. You are going to do well because you have yourself grounded. Okay.
I appreciate that. Cuz I want to do well. I have this incredible imposter syndrome of I don't know if I'm doing well enough or if I'm always second guessing myself, and I really need to stop doing that. I think my job
what makes you
has
happy?
made it.
Victoria, what makes you happy?
Well, that's a question I've been asking myself since my early 20s, you know, with being diagnosed with depression, it's kind of like, what does make you happy? And I'm like, a lot of things make me happy, but I need to find things that make me content and at ease and, to calm down. I have my dog makes me happy. The reason why I got a dog was, so I have
Sure,
something to take
sure.
care of. I do art. I write. I go for walks. Anything to be active and to take my mind off of my anxiety. That's kind of what makes me happy.
It's funny you should mention writing. I finished a short story. It's the first short story I've written probably in
Yeah.
about 10 years or so. Uh, Finished that the three. It was definitely within a week, but I finished it up that quick, and I felt good about it. I feel really good.
Yeah. You
Um,
should. That
the
takes a
reason I
lot of effort to just sit down and write because I feel you because I have a lot of ideas, but it's getting it onto paper that is very difficult to translate.
Dorothy Parker said it best. I hate writing. I love having written.
Yes, it's so good.
And that's the absolute truth. Honestly, when you're involved in a process, it's like, did you watch that bio, biopsy of, well, not biopsy, but the, the thing with Hemingway?
I studied Hemingway in high school, but I know a lot about Hemingway, and everyone's like, you should go down to the Keys and go to the Hemingway Fest they have every year. I'm like, that'd be an experience.
I've actually seen his boyhood home. I saw the cabin he
Yeah.
died in, and I've
Oh,
seen his house. I've actually been to Sun Valley, Idaho, and I've seen his grave and seen the cabin he died at. Uh,
yeah.
but Ken Burns did a nice biography or a nice film of him, and it's depressing as hell. He's he's a shitty man.
Yeah, he
He is
is.
a
He really
rotten son of a bitch.
I mean I liked his writing because it was straight and to the point. I think I we had to do The Sun Also Rises in high school. We had to study that or read that. I think I got through that book in like a day and a half
Mm,
because it was just short to the point. I'm like, I can deal with this. Um,
yeah.
yeah.
After, I mean, generally speaking, they stick you with Fitzgerald, then Hemingway, and after
Did
Fitzgerald, Hemingway is just like a breeze.
yeah. I mean from
And
going from
God help if they give you Faulkner.
I don't think I did fall. Wait.
Absalom,
Hold on. I feel like I did read something of
Sound and
Faulkner.
the Fury.
Uh, Let me see.
You happen to be talking to somebody with an English degree, Victoria.
I also have an English
Yep.
degree. I in my college, my last semester of college, because I did an English degree, and they were like, "Oh, you also have to take American literature." Because I've been taking British literature, like even my advisor at SPC, he goes, "I don't think you need to take any kind of world classes because you've done world literature
Yep.
around the globe." And he goes, but you haven't. When I was at FGCU, they're like, you need to take American literature. I'm like, I really don't want to do that. I did my time doing American literature in high school.
The worst
uh,
American literature until Twain is crap.
I can't. I just can't do it. I
I
can't.
mean, Hawthorne, yeah, Hawthorne Poe, okay. But
Yes,
beyond
Gothic.
that,
Yeah, Gothic American literature I can do, but when I had to do a whole class on Walt Whitman,
ah,
I wanted to die.
Leaves of Grass. I'm sorry,
Had
Leaves of Grass has all the pain for me as Handel's Messiah.
I just
I look to both with equal
disdain.
enthusiasm.
I because they were like it was luckily with the professor that I really liked and he was really chill, but I just suffered. I was like, is this how an American author in that time feels? Because I'm feeling it right now. I'm suffering through reading this. It's just get me out. I couldn't do it. I did it, but I suffered while doing it.
I mean, dear God, they make you, all the crap that, I mean, reading Cotton Mather's, what, what is it? There's a famous sermon that he had. By the way, hello, Jennifer.
Hi, Jennifer.
Hello.
Sinners in the hand of an angry God or something like that.
Something like that. It was I had to sit in a class full of people that are like, this is so powerful.
I'd have been burned for a witch.
Yeah, I was just, they're like, it's so powerful and I relate. I'm like, you're so full of shit. It's like, I would rather go back to doing British literature all day. I would take Shakespeare all over again because at least, you know, you had those two different rulers and that was fun for me.
Oh dear God, who's the female author? Jane
Austen. I can read Jane. I love Jane Austen. I can read her stuff any day. I love her stuff.
Absolutely.
It was wonderful.
Hi, Hunter.
Hey, I have a question.
I'm here. Sorry, we're English lessons over, Victoria. Hunter, what can I do for you?
Wait, have you ever heard of a turn of the key?
I've heard a turn of the screw. That was.
Sorry. Yeah, what am I talking about? Yeah, turn of the screw. It's
Henry James.
Yeah. You know what? I was watching. There's a Netflix documentary, or not documentary, but it's called The Haunting of Bly Manor, and it's about these like two lesbians, and they get haunted at this house and stuff. It's really awesome, but it's based off of that. So I'm gonna go watch the 1961 film later on today. But
didn't they recently do that over again? They did something at Henry James's over.
Yeah,
again.
Turn of the Screw, and I started looking into Henry James, and he has some really good stuff.
Look into GBS, George Bernard Shaw. Phenomenal.
I've been trying to get through House of Leaves too for like the past year.
House of Leaves?
Yeah. They're like, it's postmodernism. You'll love it. I'm like, I hate it. I hate it.
Is this the House of Leaves? Is this the one where the guy, like
it's
the
like
Iranian or something, has?
No, it's this house that these people buy, and the house inside is bigger than the outside, and they keep finding new doors that pop up, and there's this one door that leads into, like, let's say another dimension. But the idea is cool. It's just the way that it's written. I'm like, I would have liked it so much better if you didn't try and put some kind of bullcrap poetic spin on it.
Well, you see what I'm reading right now.
I've seen that in the stores.
What that is. Oh, Voyager.
Outlander.
I love that show.
So
read the books. Hunter, I'm sorry. Go ahead. You actually have some real stuff.
So here's the deal. In the lab, you know what I did? Like when I was doing the lab, I kind of did like I would open up all like the tabs of the calculator or of the student results. You know what I mean? I would open up the actual lab and the video tab, and then do the lab like as I was going. So because like we're some of them is
a sad story.
Not necessarily, maybe a little bit, but I was gonna say
it's not sad because he's preying upon me to give him another chance at this. Go ahead, Hunter. I'm sorry.
Possibly. Don't underestimate me. But I was gonna say, so on the final, you said it would be helpful to get your
recalculations. Yes.
If I didn't like write them down per se, I mean, some of them I did, like I had like my little scrabblings as I was like doing it, but like if I'm going to actually print them like all out again, should I just print them all out again and just do them all over, or should I just go in and just be like,
I'm not understanding print them all out over again, and I'm not understanding.
What I'm saying is, should I print them all out and then essentially do them all over again? Because I can't, like, when you go, I can't see my lab work that I've already done. You know what I mean? Like if I go and try to open it up.
You should be able to.
Well,
Uh,
I tried to open up the
you should be able
first
to.
one and
Okay.
couldn't.
What you do, you should go to submission review, go to quizzes. Right?
Submission review.
Mine is going to be different from yours. Mine is different from yours. You go to submission review, and then basically you find the
feedback on attempt.
quiz, and it's different. Mine's different from yours.
Okay, I got it.
You go from here to the arrow, and then you sneak in there, and I think it's
I just found out how to do it. You do submissions review, you go to on attempt, and then you click the actual quiz, and then it'll open up. Okay,
yes.
thank you. Because then I'll just print out all of those to get me prepared.
Okay.
I'm
glad I was able to help.
Yeah. Hey, it wasn't a sad story, you know?
Okay, good.
But you know what? You know what was a sad story is the turn of a screw, so.
Yeah. Not as sad as for a farewell to arms.
I don't know. I just like that genre. Like the more I get older, I'm like ghosts, love stories. It's interesting.
And here's me about to read all the true crime novels based off of experiences.
I'm into those. That's on my bucket list. I want to solve a cold case.
My mom's like, "How do you listen to murder before you go to bed?" I'm like, I don't know. I'm going to school for.
My mom falls asleep to a show called Snapped, and it makes me concerned for her mental health.
Oh no, it's healthy because my mom's like, "How do you go to sleep to Forensic Files?" I'm like, "It's his voice. I don't know."
True story. This is a true story. I was doing a crime scene in Lake County, California, and I was there, and the guy was, imagine this, middle of California in the summer, a week later, we find the body. All right.
Oh,
so the whole thing is finding the time of death of this guy. So we're all trying to figure out what's going on. And all of a sudden I notice there are all these newspapers. There are all these newspapers that are in the door that haven't been opened yet. So I go up to the guy that called the cops and I said, "It was this guy faithful about reading the paper every day?" And he said, yeah. Well, I mean, I'd start to talk to the lead investigator, and we're getting involved in this, right? Turns out a week later, they arrested this guy. He was the actual murderer.
Oh my God.
No way.
Criminals are dumb.
It's crazy.
I think Lieutenant Joe Kenda, he was like, criminals are stupid. Really dumb.
Well, that's because they're caught.
Yes.
You don't catch the smart ones.
All
right, ladies and gentlemen.
I have a quick question.
I'm sorry. We were having fun, and you should have yelled out. Faith, what can I do for you?
You saw my email about that one question on quiz 18,
yes. Right? Yes, I did.
I had selected the answer that was I had selected what I thought was the right answer, but it turned out that it was wrong. I'm trying to phrase this right. I'm sorry.
This is 18, right?
Yeah, the one that's due today.
All right, you mind if I pop it up?
Go ahead. Not satisfied by my explanation, huh? Well, I mean, I thought that I was just a little confused on how you worded it, because I thought what you had explained, I thought you meant that to be the correct answer, but on the quiz it's
this one?
Yeah. It's selected as energy decreases, wavelength decreases as the correct answer.
Not only do I have to give you a point for the quiz, but I have to give you an extra credit point for pointing out something I did wrong. I'm really, really not happy with you, Faith.
I'm sorry.
Nah, it doesn't sound like you're sorry. Just got to pull that lecture and got to find your last name somewhere.
So the answer is, as the energy increases, the wavelength decreases.
Correct.
Okay, because I actually got, as the energy decreases, the wavelength decreases and
No.
got it right. Am I gonna get marked off for that?
Yep.
Are we all
It's really
getting
great.
a point?
You can blame her for that, Victoria.
Sorry.
But are we
Victoria.
all getting a point for that? Because that was the one that I chose as well.
Did you bring it to my attention?
No,
Or if you didn't bring it to my attention, then no,
I
you're
was
not
just
getting a
going
point.
along with what you said was correct, so I wasn't gonna question.
No, you don't get the extra credit point because I don't have a pen that works, Faith. Kidding. All right, who else is whining about wanting a point?
Katie, I'm whining.
Katie, I will go back.
Yeah,
and
I didn't.
regrade it.
Hey! I didn't even get that.
I'll start crying.
Wait,
I'm
I
gonna
missed
go
that
back.
question too.
For some reason, what happens, guys, is literally I'll go through and put the answers down, then I'll go in and check it. And sometimes I don't hit the submit button and the correct answer, the answer doesn't get corrected. So I will go in and check it. I don't care, guys. Look at it. It is 1 point out of 1,000.
But because of it, I got an 80.
It's 1 point. Yes, I understand, Faith. You really want that?
I'm trying to get my. I'm just checking because.
All right. Do you have any idea? Do the math. 1 point out of 1,000.
0.001.
0.1%. I'll fix it. I will fix it. And I'm being magnanimous enough that I will not even change the answers that are wrong. I'll give everybody credit since I screwed up. All right. Fair enough. Fair enough, guys. Okay.
Fair enough.
Okay, good. It's 5:33. Anybody who's not here? I had 16 people. Anybody did not put in here? Okay. Got to tell you a story about Schrodinger's cat. Very, very famous analogy. All right, Schrodinger proposed an analogy. He said, basically, if you shove a cat in a box with a time bomb that has a 50-50 chance of going off, you lock the box up. Is the cat dead or alive?
Are you asking a question? Because
Yeah.
So both. So it's going to be both.
Yeah. You won't know until you open the box.
Therein lies the problem.
Are you going to see the double slit experiment?
No, not yet, Hunter. Okay, let me stay on this one right now. Okay. So basically, what happens? You don't know if the cat is dead or alive until you open the box. And the whole idea behind this analogy is you cannot apply macro measurements to micro incidents. You cannot do it, because if you do that, then you're going to destroy the entire system. You have to open the box in order to make that determination. That is the whole analogy behind quantum mechanics. If you get into the math behind it, you cannot know where an electron is, because whatever you use to detect that electron is going to cause that electron to move. You can never know where an electron is. You can know its momentum or you can know its position. You cannot know both at the same time. And ladies and gentlemen, we are going to get into Hunter, what do you want? You raised your hand.
No, I was gonna say when the cat's in the box, isn't it called superposition? Or like, you know what I'm talking about? The term superposition?
Yeah, you can do it that way. Yeah, you can think of it in that terms. All right. You can think of it that I'm agreeing with you, Hunter.
Sorry,
Why did you have to
unraise my
scrunch
hand.
up your head?
Oh, okay. Because I was looking how to unraise the hand. It's
You
kinda-
got to click on it again. Okay, guys, round about the turn of the 20th century, around 1900, they thought, hey, all the scientists, all the chemists and the physicists in the world, they thought, I've got this down. There's nothing more to discover. Energy is because of waves. We don't need to look into this anymore. So we're going to need to talk about wave properties and the wave equation. We're going to deal with the electromagnetic spectrum. Then we're going to find out that they weren't right. Everything isn't explained by wave theory. We're going to look to convert wavelength and frequency into energy and vice versa. We're going to deal with something called the Rydberg equation. And let's see what else we're doing. I think that might be it. Yeah, that might be it. So these are the things we're talking about today. When you think about waves, dear God, what did I do there? When you think about waves, you think about how big the wave is in terms of how big the size of the wave is. Get a big tsunami, it's way big. Get a little trickle thing in a pond puddle, it's going to be small. So you have an amplitude, how big the wave goes up and down. You also have something called a wavelength. That is the distance from crest to crest or trough to trough. And in order to understand the electronic structure of atoms, we need to understand about waves and electromagnetic radiation. Now, wavelength is the distance. It's the literal length from one position on the wave to another position on the next wave. That is what wavelength is. Frequency is kind of like the speed of the wave. It's how many of the waves pass a given point in a given unit of time. So we have frequency and we have wavelengths. For waves traveling at the same velocity, the longer the wavelength, the smaller the frequency. And that makes sense because the longer the wavelength, fewer of the waves are going to go through past the point at any given time.
I have a question.
Yep, here.
So the higher the frequency, like if there's more waves, that means it's more energetic, right?
If we're talking quantum mechanics, you are correct, Hunter.
So that means
no, wait, time out. If we are talking quantum mechanics, you're correct. If we're talking Maxwellian classic wave theory, it's the height of the wave that determines the energy.
Oh.
So it's a trade-off. And
Right.
that's what we're going to be getting into when we deal with quantum mechanics. So long wavelength, low frequency, low energy. Short wavelength, high frequency, high energy. So as you found out in the question, Mr. Popovich is fallible. You have a long wavelength, you have low energy, short wavelength, high energy. Okay, now the speed of light is 3 times 10 to the 8th meters per second. Can't go faster than that. So if we have the wavelength and we have the frequency, by the way, ladies and gentlemen, a funky looking V, kind of like an italic looking V, is actually a Greek small letter nu. That stands for frequency. This upside down Y, that is a Greek small letter lambda. That stands for wavelength. Your first formula, if you multiply the frequency times the wavelength, you get the speed of light. So get your calculators out, guys. What's the frequency of light with a wavelength of 585 nanometers? Now, you have to realize that a nanometer is, there are 10 to the 9th nanometers in a meter.
So we would have to solve for frequency? No, wait.
No, that's what you want. It says to calculate for the frequency, doesn't it, Hunter?
Oh, sorry. So we're calculating wavelength then.
No, Hunter, you're given the wavelength.
Oh, sorry. I was looking at number 2.
You're looking at number 1.
You're calculating for the frequency, right?
Yes. And you know the formula is speed of light, 3 times 10 to the 8th meters per second is equal to the frequency times the wavelength.
Do you
This is
just
in
multiply
nanometers.
do you just multiply the speed of light by the nanometers?
You can't do, no, absolutely not, Chase. If I want the
You would have to
frequency,
divide.
Chase, do you see Hunter's right? If the speed of light is equal to the frequency times the wavelength, then the frequency is going to be equal to the speed of light divided by the wavelength.
Okay.
But the other thing you have to keep in mind, this label is meters, this label is nanometers. And there are 10 to the 9th nanometers in every meter. 585 nanometers. Tell me what the frequency is, and I will be right back in here. I want to make sure that that conversion factor is what I'm.
Is anybody getting like
Yes,
512, 8205, etc.?
there are 10 to the 9th nanometers in every meter. Get used to starting to work with large numbers. Anybody have an answer for me yet?
I thought it was going to be along the lines of 512, 8205 dot, and then a whole bunch of decimal, or a whole bunch of numbers for decimals. It's
You got the 5.12.
So
yeah,
I got,
so 5.12, 8250, 1282.
No, I'm not worried. 5.13, 5.13. We're going to go with that.
Okay, yeah.
But
then-
what you're not including, Hunter, is the exponent. Jennifer,
would it be times 10 to the 14th?
correct.
Okay.
We're dealing with a large number. So if the wavelength is 585 nanometers, I have to multiply that by 1/10 to the 9th nanometers, which makes it 5.85 times 10 to the minus 7th meters. I divide 3 times 10 to the 8th by 5.85 times 10 to the minus 7th. Remember, when you are dividing by a negative exponent, you're actually adding. That negative exponent becomes a positive exponent. So you do end up with 5.12 e to the 14th. Second question, calculate the wavelength. If the frequency is 1.89 times 10 to the 18th hertz.
Can you write this out? I cannot do math without seeing it. I apologize. My brain doesn't work that way.
No problem. Okay. Layout. Here go this. Okay, 585 nanometers times 1 meter divided by 10 .
Yeah, I see it.
Okay, you see that, Katie?
Yes.
Simple dimensional analysis. Then we have our formula. C is equal to frequency times wavelength. So 3 . So my frequency is equal to 3. It's easier doing this. And you do this math out, this ends up being 5.12 e to the 14th. Okay? Okay, Katie?
Yes.
All
Do you
right.
need to change it to a +7 to get that answer?
Right.
Though?
What's that?
Do you need to change it to a +7
No,
to get
you don't
that
want to change it to a
E14?
positive. Katie,
Sure, Khalid. Oh, okay.
you don't want to change it because you're dividing.
Okay. I am not getting that answer. Okay.
You're not getting that answer?
No,
can we
when
get
I
a-
divided it
yeah,
by
I'm kinda
negative
confused too.
7, I got 5.13 e to the nothing. But if I change it to a +7, then I do get e to the 14th.
How are you doing this? Are you doing it with parentheses and things?
No, yeah.
Yeah?
I'll try it again.
While you're doing that, I'm going to do the next one.
Never mind, I'm good. Thank you.
Okay. I have the frequency. I'm going to plug that into my equation. And I'm going to have my speed of light equal to my frequency times the wavelength. Or I'm going to take 3.00 e to the 8th divided by 1.89 e to the 18th. is equal to my wavelength.
We don't have to change it from the hertz to anything.
Okay.
I guess it doesn't ask you to.
If you really want to know, this is in meters per second, right?
Okay.
This is in meters per second.
Mm-hmm.
This is in seconds to the -1. Okay? So when you divide by seconds to the -1, seconds goes on top and it cancels with these seconds, leaving only meters. Got it, Katie?
Yes.
All right, so this gives me an answer of 1.59 e to the -10th meters, which I can then multiply by 10 to the 9th nanometers per meter, and this ends up being 1.59 It's easier to write it this way, nanometers. Okay? Bottom line, is it that hard to convert wavelength to frequency or frequency to wavelength? That's what I want you to know at this point. Is it that hard, guys? Thank you for shaking your head, Jennifer. Now, if we are dealing with the electromagnetic spectrum, we start off with low energy waves. We can have radio waves going all over, all through America right now, right? They don't hurt us because they have low energy. You go from radio waves, the next one up on the electromagnetic spectrum are microwaves. You go from microwaves to infrared radiation. Now we're getting into something that could hurt you. Beyond infrared, we have visible light. Beyond visible light, we're starting to get into stuff that can really hurt you. Ultraviolet radiation, X-rays, gamma rays. You are going to be required to know the electromagnetic spectrum. In other words, if I ask you what has more energy, infrared radiation or X-rays? X-rays, smaller wavelength, more energy. What has more energy? What has a greater frequency? Ultraviolet radiation or microwaves?
Ultraviolet.
Ultraviolet has a shorter wavelength. It's going to have a greater frequency. Also, you need to know Roy G. Biv. Remember Roy G. Biv, guys? Red, orange, yellow, green, blue, indigo, violet. I had to sit here and think here myself. Roy G. Biv. Red light. It's closest to the infrared. Red light of the visible light has the least amount of energy. Violet light has the most amount of energy. Violet has the shortest wavelength, highest frequency.
Wow. So that's why Cherenkov radiation is blue?
That's why what?
Like radiation, like if you look inside like a nuclear reactor, the light is like blue, like in the pools. So
I would say, Hunter, I'm not going to venture an opinion on that.
Yeah, just a thought.
Not going to venture opinion on that because when you're dealing, the energy that's involved in nuclear reactors is so much bigger than visible light.
Yeah, it's like high frequency, but you said the high frequency light is going to be more like violet, right?
But then again, you can't see the radiation of light that's emitted by nuclear reactors. You can't see. It's the frequency is too high. You cannot see it. Once you go, the human eye can only see a very small portion.
So technically, there's other colors out there that we haven't seen,
or other forms of electromagnetic radiation that aren't visible light. I'd like to phrase it that way. So if we're thinking about electromagnetic radiation, red light is going to have the largest wavelength, violet the smallest. Violet is going to have the greatest energy, red the smallest. And even these bits of electromagnetic radiation do different things. Ultraviolet radiation breaks bonds. That's why when you get stuck under the sun, you get skin cancer, because literally speaking, you are breaking the bonds of your skin. Microwaves, on the other hand, what they do is they tend to make molecules rotate. Well, when they rotate, what happens is it causes friction. And it's that friction that causes things to heat up with microwaves. Infrared radiation causes chemical bonds to stretch and bend. That's kind of a useless slide. All right, so up to this point in history, in the history of chemistry and physics, everybody was happy. Maxwell came up with his famous wave formula, and it explained a whole lot of stuff until it didn't explain things. And one of the things it didn't explain is black body radiation. Okay, when you heat metal, when you heat something like steel, what color does it turn? Come on, everybody's seen the old blacksmith movies where the blacksmith throws the horseshoe in the fire and then pulls it out. What is the color of the horseshoe when it's still hot?
Orange, red,
orange,
yellow.
Why
fire.
isn't it a rainbow color?
I don't know.
Oh, that's a good point. I don't know.
It's not a prism.
Max Planck explained it away by saying energy comes in packets that he called quanta. Now, the best way for me to explain the difference between the two theories. Has anybody ever walked up a ramp? You walk up, everything's nice and gradual, and you just put one foot in front of the other, and gradually, before you even know it, you're up on the second floor, right?
Yes.
Quantum mechanics is like walking up steps. You need to exert to get up each step. You need to input a certain amount of energy. And that's how Max Planck explained that black body radiation existed. In order to get the iron to that level, you had to input one type of energy, one certain amount of energy. And that amount of energy caused the iron to go orange. If we were doing it like wave theory, then we would have gotten a prism effect. We'd have gotten something that looks like a rainbow. And amazing thing, when you come up with a formula, they get to name a constant after you. Planck came up with a relationship between energy and frequency. And he stated that the energy is equal to a constant that he humbly called Planck's constant. And he
Got it.
said the
Which
energy
is
is equal to Planck's constant times the frequency of the light. So if I know the wavelength of light, I can calculate the energy in one photon or one little packet of light. If C is equal to the wavelength times the frequency, then C divided by the wavelength is equal to the frequency, and I can plug it into the energy equation, and I can have the energy is equal to Planck's constant times C divided by lambda. So the equation we're going to use here and Planck's constant is 6.63 times 10 to the negative 34. And that's in Hertz seconds, Joule seconds. So start at it. I need you to calculate using either one of these equations. Either E is equal to hc divided by the wavelength. Planck's constant is 6.63 times 10 to the minus 34th. Or you can use energy is equal to Planck's constant times the frequency. I need to know what the frequency is. By the way, a hertz, yeah, leave it in there. A hertz label is seconds to the minus 1. Anybody have the answer to number 1? How do we get number 1? Victoria.
I'm still a little
Can you
iffy on
list-
this, so I would pass it to someone else.
Okay.
I was going to say, Professor, can you you list the so it says calculate the energy of a photon of light with a frequency. So it gives us frequency, wants us to calculate the energy. If you give us the formula, that's the formula right there, right?
Yeah, it's right here.
Okay, and what does H represent again? Oh, that's the speed of light, right? Or no?
No, that is not the speed of light. That is Planck's constant.
Planck's constant, sorry. So here, I'm going to write that down. H, Planck's constant. V is going to stand for frequency. and E for energy. So now we can actually do this. So I would set it up to E equals, and then I would put in the number 6.633 times 10. Is that negative 34?
Yes,
Okay, and what is that, J? Is that for joules?
that's joule seconds. Joules
Joule
times seconds.
Okay, so I'll do joule dash S, and then next to it, I would put the timesing factor, which frequency. So our frequency, it says, is 7.30 times 10 to the 15 power hertz. So we have everything we need right here. We just times Planck's constant times the frequency, and that'll give us energy.
Not that hard. Victoria, you got it? Victoria?
I'm getting there.
Can you go over what the units would be for that real quick? Because I see joules times seconds. Is that what that says?
Yes, it's
And
joules
then-
times seconds. That is the label for frequency.
Okay.
And the label, sorry, that's the label for Planck's constant. The label for frequency are hertz. And hertz is seconds to the -1. So if I'm dealing with the labels, I've got joules times seconds seconds to the -1. Seconds cancel, I'm left with joules, which is the label for energy. Katie, you look really, really concerned here.
I can't do math without seeing it. I cannot. I don't work that way.
Yeah, same. I'm really frustrated to watch it. I'm just looking at letters.
Sorry.
For some reason, this is coming really natural to me. I don't know why. It's like the spirit of Einstein. He's like,
all right, Einstein, settle down now.
Okay, so E is equal to H nu, right? I give you the frequency. Katie? I'm giving you the frequency. Also, Planck's constant is 6.63 times 10 to the -34th. So the energy is equal to 6.63 E to the -34th. The label on that is joule seconds. I'm taking this number, and all I'm doing with this number is multiplying it by the frequency, which was.
I was timesing it. That's why I was getting
Yeah,
confused.
I multiplied. You timesed it. I multiplied it.
I could tell you the answer. I had to times the scientific notation.
So would it be?
Can I say it?
Go for it.
Victoria, I'm taking your place right now with the answer.
Whatever, go for it.
Okay, 4.8399 times 10 to the -18.
Again, Hunter, look, I gave you a frequency. This is even a no brain sig fig answer.
Is it
Don't make me take a
8.4?
point away
Come on,
from
dog.
you.
It's only 2
it's
sig
4.
figs.
Okay, Hunter?
4.8?
Hunter,
Or 3.
your mic's not on, Hunter.
Oh, sorry. It's going to be 4.84 times 10 to the -18. Because I'm rounding.
Okay. All right. Second question. Calculate the energy of red light.
Was that
It
right?
has a wavelength of 720 nanometers. What you're doing is you're using two equations to manipulate to get the answer you need. Two equations you have.
It gives us the relationship, right? Like,
that's number one.
Number one, like, why did we multiply? I know the equation is multiplication, but like on the previous slide, it showed dividing, I thought.
Where? On the previous slide?
Looked like it.
I can tell you the answer to that, because on the question you're thinking of, we divided because we were trying to look for the frequency. We weren't looking for the energy, because energy is on the left side of the equation. We were looking for frequency, but we had one. We only had, so
Mariah, are you referring to these questions?
No, I think it's the one that you had set up that it looked like it was
dividing.
Like
yeah,
HC divided
yeah.
by
That's
wavelength.
why I divided it, because it looks like HC divided over wavelength. So that's why.
It is. All right.
So why would you?
Because he said that was two different equations you could use.
All right.
Yeah, I just went with E equals HV.
All right. You have two equations. Speed of light is equal to frequency times wavelength. So C divided by wavelength is equal to the frequency. Mariah, does that make sense to you?
Yes.
If I've got my frequency, my speed of light is equal to my frequency times my wavelength, then the speed of light divided by the wavelength is equal to the frequency, right? Mariah?
Yeah.
I also have another equation, which is my energy is equal to h nu. So if my frequency is equal to my speed of light divided by my wavelength, I have another equation, E is equal to hc divided by my wavelength.
How do you do the negative exponents in calculators? It's still not letting me do it. I don't know what is wrong with it.
Okay, do you have a negative, not the negative subtraction sign, Chase? Do you have, like, at the bottom of your calculator? The only thing I can do is just put it to you here. Do you see there is a negative sign? This makes things negative, whereas this one over here is the subtracting button.
Okay, that makes so much more sense now. Thank you.
All right. The question I have 720 nanometers. The question I have is how much energy? You have everything you need here except one more thing. Now you need a couple more things. And, oh yeah. Okay. All right, we're going to go with Katie.
Yes.
I have 720 nanometers. You got to tell me how much one photon of that energy is worth, how much energy one photon has if its wavelength is 720.
Okay, so you would just do the H multiplied by the C and then divide it by the 720, but do you have to convert things to?
What's the C's label?
Oh yeah, I forget what you said that was. That is
little m meters per second.
So do you have to, you said like the nanometers to meters is negative 10 to the 9th. So do you have to do something with that number?
Well, what do you think?
Yes. But do you divide it?
Well, 10 to the 9th nanometers is equal to 1 meter. You have 720 nanometers. You want to know meters, right?
Yes.
So what's going to go on top?
The meters?
Divided
Okay.
by,
Okay, divided. Okay. Oh, oh, dropped all my stuff.
so I do this conversion. First thing I do is I convert nanometers to meters. I get 7.20 times 10 to the minus 7th meters. Now, somebody suggest where I go next.
Set up your equation.
Tell me what to do.
So it would be E equals 6.63 e to the negative 34 times.
I can't type that fast.
Okay. Times 3.00 e to the 8th. And then all of that divided by 7.20 e to the negative 7.
Simple enough, guys. All I got to do is plug. This is my equation for energy related to wavelength. I got to plug in Planck's constant, which is 6.63 e to the minus 34th. Multiply that by the speed of light. Then what I'm going to do is I'm going to divide that by the wavelength in meters. This is seconds on top. This is seconds below. That cancels. This is meters on top. This is meters below. That cancels. The only thing left is joules. You do that math out, and you end up with a number 2.76 times 10 to the negative 19th joules. Doesn't seem like a lot, does it?
You said 2.76 e to the
Negative
30?
19th, I believe.
I got 33 or negative
Nope.
33.
That's definitely wrong.
What did I do? Okay.
Again, you're gonna have to be careful. Type in 6.63. Do you have an EE button?
No, I'm just doing 10 and then hitting the up button. I'll figure it out. Let me do it a couple times.
Katie, put your calculator to the camera. All right, do you see on there, there is an EE button. Turn it back to you. Do you see there's an EE button on there?
Yes.
All right, what I want you to do right now, type in 6.63.
Mm-hmm.
Then type in, do you need to do a second function?
Yes.
Hit
Okay.
second function EE.
Mm-hmm.
Type in, look at the negative sign that's at the bottom.
Yeah, negative 34.
Times.
I have it in
Times. Hit the times. 3.00. Second function EE8 equals.
Okay.
Divide that by 7.20. Second function EE negative 7.
Okay, I got that. Thank you.
Trust me, that is a lot easier than trying to do those parentheses things. All right, normally speaking, if you take a light source, shine it through a slit, what you end up doing is getting polarized light. Then you hit that through a prism, you get a rainbow. But yet, how many of you have ever seen fireworks? Everybody seen enjoy fireworks? You get reds, greens, yellows. Why do you get colors? If I'm putting energy into an element.
Is it because of heat?
No, it's because it accepts energy in specific wavelengths. That's how we're getting different colors. In the case of sodium, sodium will absorb in the yellow region. So that's why if you have a yellow firework, it's probably made with sodium. Hydrogen has different lines. It has 4 of them. Niels Bohr tried to explain this. And what Niels Bohr said was, electrons travel around the nucleus, but what they do is they do it in very specific orders. And the electron, if it's at the lowest level, has a certain amount of energy. If that electron gets promoted to a second level, it has more energy. If it gets promoted to a third level, more, and so on and so forth. Now, as long as energy is input into that electron, it stays at the higher energy level. But what happens when you take that energy away? It wants to go back to its ground state. When it goes back to the ground state, it releases that amount of energy. And when it releases that amount of energy, it does it in very specific colors. So this one is basically moving of an electron from like the second orbital down to the first. This is moving it from the third down to the first, fourth down to the first, fifth down to the first. So if I look at it from this aspect, if I put enough energy to get that electron to the second level, when the energy is taken away, the electron will relax. When it relaxes, it releases energy in the form of a light. It doesn't do it in a rainbow because there is only a certain amount of energy that can be released. And a certain amount of energy that can be released coincides with a color. So what Bohr suggested was he suggested a solar system type of model of the atom. He suggested that you have a nucleus. Around the nucleus, you have the first orbital of electrons. There is another orbital beyond that, another one beyond that, and another one beyond that. It looks like a solar system. And the energy is only permitted an orbital that has a specific energy. If it's in an allowed energy state, it will not spiral into the nucleus. And so energy is only emitted or absorbed based upon those different levels. So if I'm looking at an aluminum atom and I want to put energy in here, I can take this electron with a certain amount of energy. I can promote it out to the third shell. And as long as that electron is seeing that energy, feeling that energy, it will stay out there. When I take the energy away, that electron is going to want to go back to where it was originally, its ground state. When it goes back to its original shell, it will emit the amount of energy difference between the first and the third shell. No energy between that. This area between it, it cannot have enough energy to be right here. It has to be either in this orbital, or this orbital. Is that making sense to you all? Now, actually, this is kind of a good story. It's kind of like Einstein in the patent office. Normal people can get involved in science too. Way back in the late 1800s, there were two scientists, Balmer and Reiber, that calculated, that figured out a formula that would predict these energy lines that occurred when we had hydrogen promoted from its ground state to a higher state and then have that energy released. They were able to predict that energy difference. And that equation is energy is equal to Rydberg's constant. We're dealing with this one down here. Why is this not highlighted? Any case, the energy to go from one state to the other is equal to 2.18 e to the minus 18, Rydberg's constant, times 1 over n final squared minus 1 over n initial squared. This means if we are going from a lower state to a higher state, is this number going to be negative or positive? In other words, if we're going from the first shell to the second shell, is this number going to be positive or not negative? Put in the numbers. You're going from one, initial 1, to the second one, 2. And final is 2. 1 over 2 squared is what? What's 2 squared, guys?
1/4.
So 1 over 2 squared is going to be 1/4. All right. From that, you're subtracting 1 over 1 squared. Is this term going to be negative or positive?
I think it'll still be positive.
1/4 minus 1?
Oh, my bad. No, it's negative.
This part is going to be negative. That makes the energy negative. Remember when we were talking about exothermic versus endothermic? What is the sign of an exothermic reaction?
Positive.
Other way.
Negative, my bad.
Negative. So if you're going from a smaller end to a larger one, your thing is going to be exothermic. I knew there was something wrong with this slide. There should be a negative, and this is not allowing me to fix it.
You may need to hit that enable content in order to edit, possibly.
Here, I fixed it for you.
Thanks, Keith. So the change in energy level is equal to negative Rydberg's constant times 1 over n final, where it ends up. Keith,
Yes.
stop. Stop. Thank
Okay.
you. So my change in energy going from an initial shell to a final one is going to be equal to negative Rydberg's constant times 1 over the shell it ends up in squared minus 1 over the shell it started from squared. What is the frequency of light emitted from an electron in the hydrogen atom going from the third energy level to the first? Tell me what I'm doing. Can I, if I'm going from the third energy to the first, do I know the ends?
Yes.
Do I know what R is?
Yes.
Can I calculate E?
Sure.
If I have E, can I use this other equation to find out what the frequency of the light is?
Yes.
Victoria, set it up for me.
No. um, you're going to do, well, you have to find E, right?
Okay, got to find E.
So you would do 6.63 times 10 to the negative 34.
But I don't know frequency or E.
Okay, so we can't find E. That's cool.
Can you, wait. Can you find E?
Yeah, I don't know.
Is this like a two-step? So we have to do what we did before and then
Go ahead,
put,
Chase.
you know?
Tell me what
So
to do.
So you'd put the H, so it'd be 6.63 times, no?
You would
Again, I can't use this equation yet because I have two variables. I don't know what E is, and I don't know what my frequency is.
So would it be, the first equation would be E equals negative 2.18 times 10 to the negative 18?
Why would you make it the negative?
Because you have to first
Because
start with the change of E.
this is the formula,
Oh,
Chase.
okay. Okay.
Okay.
All right, who was talking?
That was Jennifer.
Jennifer, come on, continue on, Jennifer.
I would,
Doing
and then
good.
it would be times, now this is where I'm confused. It would be 1 over, would it be, that's NF2, right?
Where is it ending up?
The
third.
So it would be 1 over 3.
Wait, read the problem. Where is it ending up?
Oh no, it'd be 1 over 1 squared minus 1 over 3 squared. Okay, I got it. Yeah, it goes from that to the, okay.
Do you see that, Victoria?
I'm seeing it, Professor.
And then once you find that, then you can use the other equation because you have the H.
Then you can solve for, yeah.
So,
Professor, would it be 1 over 3 squared or 1 over 3 cubed?
3 squared. The squares are there.
You put 1 over 3 and then 3.
1 over 3 and the, oh, no.
Okay. Extra credit?
This is what, actually, Chase, you get it.
Yes. Let's go.
Your last name, Chase. I got
Glenn.
you. That's your second. Okay, so. So I do this math out. 1 minus 0.111 equals 0.88889 times 2.18 EE to the negative 18th. This equals 1.93 E to the minus 18th. Okay?
And now you can find your now you can find E.
Now I know that E is equal to H nu, 1.93 E to the minus 18th joules is equal to 6.63 E to the minus 34th joule seconds D. So I just take the 1.93 E to the minus 19th and I divide it by 6.63 E to the negative 34th. And I end up with V is equal to 2.92 E to the 15th seconds to the minus 1. Can I determine what the wavelength of this light is?
Yes.
I'm sorry. Thank you, Jennifer. How do I determine the wavelength?
You take it's C equals V and the upside down Y. And that would be the 3.00 E to the 8th.
So I get 3.00 E to the 8th
Equal to
divided by
oh yeah,
the frequency I just got, which was 2.92 E to the 15th. That will equal my wavelength.
Question.
Yep.
Back when we were solving for E, I did the calculations and I got that number, but I got a negative.
Yeah.
Where did I go
Yeah.
wrong?
Yeah. You're right. This number should be a negative.
Okay.
The thing about it is you can't have a negative frequency.
Okay.
So you just are going to drop the negative.
Okay, got it. Thank you.
All right. Thank you for Kaylin. I'm just giving out points left and right. You got your third.
Hooray.
Is it, I don't know if I'm reading this right. Is it 1.02 times 10 to the negative 6? Question mark?
I'm sorry.
Never mind. I thought I had the answer, but I'm not sure if it was right. I said times to the negative 7th. Okay, never mind. I said negative 6.
All right. And what you're going to want to do is you're going to want to multiply this by 10 to the 9th nanometers per meter. To get it into a normal number. Okay. Okay, I said 100. All right, actually it's 103. I didn't round correctly. That's all I really wanted to do today. I wanted to get you to work with these equations. And remember what those equations are. First one we did was C is equal to frequency times wavelength. Energy is equal to h nu, Planck's constant times the frequency, or energy is equal to hc divided by the wavelength. Energy is also equal to negative RH
Is that V thing frequency?
Yes,
Okay.
I can't.
No, you're fine. I just don't know what all the letters mean right now.
Rotten dog. I believe that's all the equations that I have. That's really what I wanted to do today. And I wanted you to start to get used to manipulating, using these equations in sequence with one another.
I have a question.
I'm here.
Is the RH the 1.097 or is it the
No, it's the
2.18?
2.18.
Because I thought on the original slide it said the 1.09.
This is R. That's the Rydberg constant. Okay. The original slide. Yeah. This is true. But you have to understand that this is, all right, do you see what it's equal to here? Who's talking?
Mariah.
Mariah, okay. What we've done is we've gotten, this is no longer equal to the energy. Okay, Mariah?
All right. So when it's the energy, it's the
When it's the energy, this is the equation.
Okay.
The equation you see right here is the one that you use. If you wanted to specifically solve it for the wavelength, you would, instead of using 2.18, you would use 1.097. Don't worry about it. Forget about this one. Forget about it, okay? That is why this number is different from this one. The Rydberg constant is 2.18 times 10 to the minus 18th. Any questions, ladies and gentlemen?
Professor, I'm wondering if you don't mind, can you upload this particular presentation on the site?
I believe
It's already on the website.
it is on there.
Because
well, I mean,
you know, you added a couple of slides with the calculations and things like that. If it's possible, if not, that's all right.
I can try.
Thank you.
Can you go back to the really mathy slide real quick?
The really bathy?
Mathy. When we were solving for wavelength.
That one?
Yes, please.
Is this the one?
Yeah. Thank you. I lost myself somewhere.
I've lost myself every time. It's called dementia. Guys, I get to have the Beatles song sung to me this year.
Stop.
You know, many years from now, will you still be sending me Valentines?
Oh, I remember you're gonna They're gonna name a constant after you soon.
Yeah. The constant they're going to name after me is how long can he sit with his butt in this chair?
Yeah, I know you want to get back in the classroom.
Like you don't believe. I'm actually going to be there in the summer. Chem 1 is face-to-face. Any questions, guys?
I just have a quick one. When is the last time we're gonna be meeting?
At our last actual class lecture?
Yeah.
Including next Tuesday?
Just the final class.
Next Tuesday.
Okay.
Next Tuesday, we have the lecture on quantum numbers. That's
And
where
the
we're going
test
to actually
the
get.
test is still going to be next Thursday, right?
The test is next Thursday.
Isn't our lab final next Thursday as well?
The lab final, I think, is open until 10 p.m.
Okay, that makes it
We
better.
have
But
time.
it's still a
Yes.
test. and a
Well,
final.
I think there's some of us who have it on Tuesday and some of us who have it on Thursday for the lab.
Oh, I did not think of that part.
And Thursday, no, that's wrong.
Hey, Professor.
Let me think about that.
I was just going to say I'm going to leave because I'm going to sell my old car really quick.
Okay, bye. It's past time anyway, Hunter.
All right. I'll be
I'm not going to talk about anything more. Other than this. Guys, how can I fix this for you? I have to give the test.
Just get rid of the final exam.
What's that?
Just get rid of the final exam.
I agree, please.
If you were good enough, you would not have to take the final exam.
Are you saying Thursday the lab, the test, and the final exam is due?
Hunter, you have lab on Tuesdays, don't you?
Yeah.
Our practical
is going to be on Tuesday.
For the lab.
For the lab.
Yeah, okay.
Test 4 will be on Thursday.
On the My Courses for the lab, it says the lab would be open until 10. So even if we still go to lecture ends at 6:45, and the lab is only 2 hours, I believe. So we'll still have time.
Yes, Jennifer, absolutely good point. But the problem, that you're going to be going back to back then.
Mm-hmm.
I will open the lecture test also from 8 a.m. until 10 p.m.
So can you, on Tuesday, do we have to come to class and then also take the final? That seems like a lot. I don't want to stay up till 10 p.m.
Katie, I'm sorry, but tell me something different. You don't have to do that, Katie. You can take the test. Test is open from 8 until 10.
Okay, and then Thursday we have
the lecture.
What, test
test
4?
4 the lecture.
And then the following week is the lecture final, correct?
Correct, on May 3rd, I believe.
I thought it was the 6th.
Yeah,
it's the 6th.
May 6th, yeah, next Thursday.
Because I'm getting oral surgery on May 3rd. It better not be May 3rd.
May 6th.
Woohoo.
It is the succeeding Thursday. You have a week from test 4 to the final.
Oh, and for next Thursday, do we not have like Zoom class?
Nope.
Okay, that will make it easier with the test and final.
Your final Zoom lecture is going to be on Tuesday. And really and truly, unless you're good at quantum mechanics, I would not miss that lecture. Can anybody make a suggestion for next Thursday? Those of you that are in the lab. Right now, you're scheduled to do back-to-back tests. 5 through 10 o'clock.
Can you not make their practical on Friday?
Yeah, can you make it open maybe for the
No, I
weekend?
can't
like,
do anything
open
about the practical.
Oh,
I can't do anything about the practical. I might be able to maneuver something about the lecture.
I cannot do anything on Friday. I work the entire day.
Mariah, then you tell me.
I mean, I can still take it on Thursday, like, because the fact that it's from 8 a.m. to 10, like, you don't have to really take them back to back. You could take some time in between to not do anything.
Well, the thing is, a lot. I don't know. I mean, I don't speak for most, but a lot of us work Monday through Friday, like 9 to 5 jobs, 9 to 6, etc. So I feel like for the final, maybe have it like so it's not due one day.
The
like
final, Gase, we're not talking about the final.
Or not the final. I'm sorry, the test. Like the test would be due. Like you have a day or two to be able to squeeze in and take the test. You know.
Gase, make your best argument and email me, okay?
Okay.
Guys, anybody that is really objecting to taking both the final and the lab, email me specifically. I want a specific email from you with your best argument, okay?
Sounds good.
I'm not saying I'm going to turn you down, but I just need you to email me, okay?
when did you say that grades have to be in?
Fairly quickly. I think it's within 48 hours of the exam.
From the final.
From the final.
Okay.
There's nothing I can do about that. That is something that they really harp on. Professors, they want to get you to get your grades in.
That's fine. I think I told you that I'm getting my second COVID shot the day before the finals. So I'm like freaking out that I'm going to be too sick to take it. I'm still going to take it, but I didn't know if like it can be open until like either late or early into Friday morning or I could just do my best and
email me.
suck it up and get through.
Email me, Victoria.
Okay.
This is, are you talking about the final? No, I
Yeah.
can't do anything about the final.
All right. Well, I'm
I can't-
SOL.
That's, if I can mess around with the test 4, I can't mess around with the final.
Okay.
I'm sorry.
It's all right. I'll get through it.
Hey, Professor, before I forget, what is the second pop quiz? I was looking at my grades, and so I'm just trying to understand, like, when do the grade, the lowest grade drops, and when does the that all happens at the end, though, correct?
Yeah, I think I put in there, didn't I put in something about when I was going to add the participation in the homework grade?
That's what I'm trying to look
Yeah.
for.
You have it. Hold on. You said the participation grade will be entered as of May 5th at noon.
Yeah,
And that's also, and that's when the homework grade will be added in. And then I think you have the pop quiz open from the 25th to the 30th.
Stop share. You worried about the pop quiz, guys?
I just want to know what the second pop quiz is. Oh,
I'll show you what it is if you want.
but it's not open now, is it?
If it's anything like the first one, I'm excited.
I know, right?
Yeah.
Where is it? Submission review. There we go.
It's going to be like a police interrogation. It's going to be a second pop quiz.
It's open on the 25th. That's a, why do I do things? Crap. Let's do it this way. I can open it now if you want it. I'm not going. Why did that do that? crap. If you're really interested, stick around. It's not all that interesting, though. It's interesting from my viewpoint.
I have another question.
Good. Somebody bring sanity back to me, please.
Will there be any more discussion prompts posted for this week? It's been kind of dry in the forum.
I think I've kind of, didn't I end that as well?
Oh, I don't know. When you sent the email listed with everything that was due for the remainder, there were discussion posts listed. Maybe I got mixed up. Thank you.
Okay. Did I have any discussions for this?
I think the last one we did was like gas laws or something like that.
Yeah, it was like due April 11th.
I don't have any discussion assignments put in there. Is this
Okay.
Katie?
Kaylin.
Kaylin, sorry. I don't have any discussions in there.
Yeah, the assignments due week of 11 and beyond says April 25th, 3 discussion questions.
I mean, you
But
don't
if
have
you don't
to.
want to do them, we don't
Yeah,
have
that'd
to
be
do
kinda-
them.
Yeah, let's not go ahead and do them. Just kind of drop them off.
What discussion questions?
I don't know.
I don't
There
know.
are none. That's the problem.
There are none. Well, there's none that are
Correct.
being, there are none that are
Cool.
being requested.
Okay. Check that off my list. Thank you.
Guys, all I was doing those discussions was to get you talking amongst yourselves.
Figured.
That's all I was doing that for. It worked really well in the fall because they really enjoyed that. That seemed to help them out. You guys have had less enthusiasm for it, shall we say. Okay, now.
Every person for themselves.
Yeah, that's kind of what.
I think we've been talking outside of that forum.
Yeah.
Yeah, we have a virtual chat that Victoria made, and we've been using it all semester to help each
So
other.
you're talking behind my back.
Yes.
Yes.
All right.
But we're actually using it for like lab and for lecture and homework and posting like videos of like how to do this just in case somebody needs it or the formulas.
Yeah, we help
Well,
each other
great.
out.
No, great. I don't care. I'm not married to my forum or my discussion thing. I just wanted you to be able, I just wanted you to have a conduit that you could talk to each other. Okay. Second pop quiz. During the past semester, I employed various tactics to get you to learn the material. Please look at the following list and tell me the 3 methods that were the most effective and the 3 methods that you feel were the most ineffective. First question of the pop quiz. Second question. This really is a thing in my craw, guys. Generally speaking, I write all those announcements and emails of the assignments for the week. It takes me 3 hours to do that for all the things. If it's worthwhile, I will continue to do it, but I just need you to know, I need you to tell me whether it's worthwhile or not. Discuss the Zoom meetings. Did you object to the last minute invitations? Were they effective? And what could I have done to improve them? Discuss the online outline. Should I continue with it? Talk about the quizzes. Long question there. Homework, another long question. Do your best to answer this. Discuss Discuss the discussion forum. Did you use it? Was it effective? Did it help you to get to know each other? Are you getting the gist of the pop quiz here, guys?
So we're basically doing another student survey, but without the college knowing.
I am not allowed. I am not allowed to really do a survey. Okay?
But it's a quiz. It's not really, I got you. Don't worry.
I really am. I really do use the input I get from this to change things. Okay? I'm not allowed to use this and read the comments before grades are posted. So I will not look at these until until I get back from Savannah for sure. Okay. By the way, guys, final question. If you do put something on Air My Bitches, Rate My Professor, please don't do like the idiot that just put up a comment. He really reamed me, gave me a 1 rating, and then he said this was for course 2046. Trouble is, I'm not teaching that course this semester. So be aware of when you're rating something on that, what it means, all right? So are you really worried about the second pop quiz?
No.
Perfect. Thank you. Thank you so much. And you said it's going to be a high grade. It's like a 20% of overall, right?
Huh?
Pop quiz. You're going to give us a lot of points on this pop quiz, correct?
Huh? Say what?
Professor, I gotta go. Thank you. Have a good night.
Bye.
Bye, Professor.
I got to get this loaded up so I can talk to my class tonight. Okay, guys?
Have a good night.
You have a good night as well.